Hello and welcome to another one of these ADD videos. Today we're going to be looking at a slightly more intermediate example than just a constant, an exponential function. And we're going to do the Laplace transform of this exponential function. So, as always, the first step is to write down the definition, okay? And we're going to be using this instead of the table, which is much easier. We already should be able to get to the answer if we were using the table. So, if we were using the table of Laplace transforms, we could go to e to the kt and realize that it's supposed to be 1 over s minus k. So, k in this case being negative 2, we should get 1 over s plus 2 when we're done. Let's see if that's indeed what we get. So using the long definition, what we got to do is first plug in our f of t. So there's that step right there. Then we have to account for the fact that it's an improper integral, so we take the limit as some constant, arbitrary constant, approaches infinity and replace that infinity with that constant. I know it seems like semantics, but that's the way you do improper integrals. So now that we've accounted for the infinity, we have to evaluate the integral. And the way we got from this step to this step was by using this multiplication of same bases, you add the exponents rule. Okay? So anytime you have two like bases, add the exponents, you get this. Then you can factor out the common t, and then you will get this here. And then you should recognize this to be a u substitution. So you let u equal the exponent, du it becomes that, solve for dt. Plug in, it's e to the u, because that's what u equals. dt equals du over negative 2 minus s. When you integrate e to the u, just get e to the u, and that constant comes along for the ride. Then plug back in what your u equals. And now it's for the limit evaluation. So to evaluate the limit, what we have to do is we have to first plug in the a, minus the 0, top bound minus bottom bound. Then plug in the infinity. If I have infinity times two constants that are negative being added, would be another negative constant times infinity is a negative infinity. Anything times 0 is 0, so we're left with e to the 0. Then at that point I also factored out a negative 1 out of the denominator, so I could combine the negative and the negative to give me a positive. Anytime I have a finite over an infinite, that's going to give me 0. If you guys remember, the e to the negative infinity comes in the denominator, with the negative 2 minus s. So that would then become 1 over negative 2 minus s times e to the infinity, now positive because it's in the denominator. And then you're going to get this negative sign can factor out and then go to the top and then give you that negative 1 over infinity. Any finite number over infinity always goes to 0. And then we're left with the 1 over 2 plus s, that what we expected, or s plus 2, however you want to look at it. Remember the chart, for those of you that forgot, e to the kt, k was negative 2, we'd plug in a negative 2, s minus negative 2 is s plus 2. And that's what we got. Alright? So again, recap the steps, write down your definition, plug in your function, account for the improper portion of the integral, simplify using whatever algebraic rules you need to use, integrate, in this case it was a u sub, you might have to do by parts, so be up on your integration game. And then at that point, evaluate the limit. You might have to practice some infinite limits. There are scenarios where you might have to do some L'Hopital's rule if you get infinity over infinity, for instance. So make sure you do enough of these to where you got it down pat. All right? Hope I've clarified things a little bit for you. Make sure you check out the more advanced example video. Practice, practice, practice. Thank you and have a nice day.